Hello everyone, welcome back to another video in our Module 2.1 series, Networks. In the most basic form, think of a network as connecting two or more devices. If you are able to connect two devices together, then you already have a network. It may be as simple as connecting them through a wire. Before, the Game Boy Advance would be connected through a Game Link cable so you would be able to trade your Pokemon. There, you already have a network because two devices were connected. It can be also as simple as making a cell phone call. Two devices connected together, therefore you have a network. With that being said, let's get started with our lesson on networks. We will be learning three topics today: wired media, wireless media, and the transmission media and protocols. So let's get started. The three major wired media are twisted pair wires, coaxial cables, and optical fiber. Twisted pair wires are the insulated copper wires also used for ordinary telephones. They are the most common wired medium, partly because the telephone companies already installed them for voice communications long before they were used to transmit digital data. So these twisted pair wires can transmit both voice communications, right? But right now they are being used to transmit digital data. These wires are somewhat fragile and susceptible to interference. But because of their thin, flexible shape, it lets them wind easily through ceilings, walls, and cubicles, thus making them popular for apartment and office buildings. Next, we have coaxial cables. These cables have a single inner conductor wire, typically made of copper, surrounded by insulation, which is then surrounded by a mesh-like conductor. These are thicker and sturdier than twisted pair wires and were deployed by cable companies to carry television signals. As a result, they have been installed in many homes and buildings. Last, we have our optical fiber cables. They transmit bits by means of light pulses along a glass or plastic fiber rather than electrical signals over a conductor. Optical fiber differs from twisted pair wires and coaxial cables first in its physical composition. So it is made up of glass or plastic fibers instead of conductors like what we have in twisted pair wires and coaxial cables. Next, instead of electrical signals, right, that instead of sending data through electrical signals such as twisted pair wires and coaxial cables, they use light pulses to transmit bits. Remember what bits are? Bits are binary digits or the medium in which we transfer digital data. This medium, optical fiber, right, is ideal for very long distances since the signals attenuate less than electrical signals do, so there is less interference with them. Underneath our ocean floors are thousands of kilometers of optical fiber cables. The thin fibers can also carry many more channels simultaneously using different wavelengths of light. So, the bandwidth of optical fiber cables are very, very high. I will be adding a supplementary video on optical fiber cables on Moodle, so do check it out. Next, we have something that we are all familiar with: wireless media. Wireless media make use of electromagnetic waves. Remember the EM spectrum discussed back in high school: radio, micro, infrared, visible light, ultraviolet, gamma rays, etc. This is the medium used by wireless networks to transmit digital information wirelessly. The waves we use for wireless telecommunications are longer than visible light in the ranges of radio waves and microwaves. Microwave transmission sends signals in the gigahertz range. The signals using microwaves can be transmitted to satellites as well. Cell phone infrastructure, on the other hand, relies on radio waves in the 800 to 1900 megahertz range. Different cell phone networks use different bands along this range, with separate technologies to encode transmissions and take best advantage of available frequencies. And last on our wireless media, something we are all familiar with as well: Bluetooth and Wi-Fi. Wi-Fi, short for wireless fidelity, refers to a computer network in which connections rely on radio waves for transmission. These radio signals emanate from the antenna of our wireless router, which has a wired connection to the network. Bluetooth, on the other hand, is a technology that also uses radio waves in the same range as Wi-Fi. It is commonly used for wireless connections over very short distances, such as your speakers, AirPods, and sending files over a short distance, such as AirDrop. And before we end this slide, there is a checkpoint quiz. What are the two waves in the electromagnetic spectrum we use for wireless media? Do expect that question to pop out on Moodle. Next, let's move on to the type of networks. First, we have client-server architecture. Looking back to our lesson on web servers back in our hardware video, the network architecture is the same. Remember that there is centralized multi-user computer, or what we call a server, where all single-user computers, or what we call as clients, connect to. The server, the one in the middle, is a high-performance host running programs and storing data. This server is accessed by clients such as your desktops, laptops, and smartphones. This approach is highly centralized because most of the work, the running of the programs and storing of the data, is done by your server. That's why it is centralized. The next type of network is peer-to-peer. This is a decentralized approach. In this approach, sorry, there is no central server and computers can share files, printers, and internet connection with one another. The computers, or what we call nodes, on a decentralized network are peers in the sense that each one can offer different services to the others and none is a centralized server. Peer-to-peer networks support file sharing and other services on the internet. Torrenting uses peer-to-peer architecture. Familiar terms when you torrent are seeders and leechers. Seeders are those who have already downloaded the file and are uploading them. And leechers are people who are sharing what they have and are downloading what you have. So, if ever you are downloading anything through torrents, you are also actually uploading them for others to download as well. The more peers there are in a network, the faster the download and upload will be. So just a quick trivia, I've been asked this question multiple times. Sir, is torrenting bad or illegal? And the answer is no. Torrenting is not illegal. The torrenting of pirated software and other materials is illegal. Okay, so know the difference. Next up, last, is our network protocols. The network we are talking about here is how you would connect to the internet. You connect through the internet through Ethernet cables or Wi-Fi. The cables or Wi-Fi signals are both connected to your modem router so that your device can connect to the internet. What I want to focus on is the third point, TCP/IP. This stands for Transmission Control Protocol Internet Protocol. TCP/IP deals with networking layers that define how data are packaged and transported and where they will be transported to. Let's start off first with the IP portion, okay, or Internet Protocol. IP defines where will the data be sent, okay, the destination, where. IP is the IP address. Every device connected to the internet has an IP address. This is a logical address that tells where the data or what we call packets, data or packets, should be sent. Again, IP is a logical address that tells where the packets should be sent. Packets are your data. So for example, you want to connect to moodle.ateneo.edu. And the server of Moodle will know where to send your data because you have your own IP address as you are connected to the internet. Next up, we have our Transmission Control Protocol, TCP. TCP determines how your data will be sent. If IP determines where, TCP determines how. Your data is sent and or received through packet switching. In packet switching, the first step is breaking down your data into many small pieces. These small pieces are then sent over the internet. As they travel through the internet, they don't have to be together. Okay, that's why you broke them down into smaller pieces in the first place. Some of them can arrive earlier or later. Some of them can take longer routes. Some of them can take shorter routes. It doesn't matter which route they take, depending on the traffic in the internet, as long as they arrive in the same destination. They know where they need to go because of the IP address, as said earlier. Once they arrive in the destination, the small packets reassemble again, forming the original file. Again, the steps to your TCP or packet switching are: you break it down into smaller pieces, go to your destination, then you reassemble. This is your transmission control protocol, or TCP. It is done through packet switching. An example I usually give, I don't know if it is still relevant because most of the freshmen here have not been on campus, but I will try to put this into perspective. I apologize if these places are unfamiliar to you yet, but do try to visualize on how this works, okay? Imagine we are all in a classroom setting, in a non-virtual, like live synchronous classroom setting. We are all in we're all in a building called CTC. Okay, that is where our classroom is, and you're all on your designated seating arrangement. I then ask the entire class to move to another building called Bellarmine Hall. Okay, we're gonna move this entire class to the classroom, to another classroom. So because I said, right, the entire class then disperses walking to Bellarmine Hall. Some might take the Red Brick Road route, some might take the Somme Forest route, some will pass by through Gonzaga Hall and through EDSA Walk, right? So it doesn't really matter where you pass through, as long as you all arrive in the classroom designated in Bellarmine Hall. Then everyone in that Bellarmine Hall classroom will sit down in the same seating arrangement as they were in the previous CTC classroom. This is how packet switching works. We break you down into smaller pieces. I send you off. You all know where to go. And once you arrive in that classroom, I want you all to sit back in your same seating arrangement. And this is how TCP/IP works. And this is how data is transmitted over the internet. And with that ends our lesson on networks. In the next video, we will be having a lesson on databases. See you then.